This is Mr. Martin. These are video notes for Geometry Advanced, section 9.3. By the end of this video, you should understand and be able to apply the ratios of the sides. First, to solve special right triangles, we're going to be talking about two special right triangles in particular in this video. So the first one that we're going to talk about is 45-45-90 isosceles right triangle. So its name comes from the fact that we have a right triangle and its isosceles, which would make each of these angles 45 degrees. So 45, 45, 90. And although we know how to solve right triangles already, a lot of times we're dealing with decimal answers and we want to deal with exact answers instead. So we're looking at the 45, 45, 90 isosceles right triangle, and let's go over the parts of the right triangle before we get going here. We've got the legs. So we know that the legs are going to be the two sides that meet at the right angle. So that's going to be side AC and side BC. And then the last side would be the hypotenuse, so that's side AB. And since the triangle is isosceles, we know that AC is going to be congruent to BC. Two legs of an isosceles triangle are congruent. Alright, so let's use this property of isosceles triangles to help us find the length of the hypotenuse for a few 45, 45, 90s. And then let's remember, since it's a right triangle, we can use the Pythagorean theorem. So that's going to be key in helping us figure out the special ratio of these sides. Alright, so let's start by making AC 1. Alright, and I've got, this is my right angle. I know these are going to be congruent, which means that this side's also going to be 1. And we'll let this side be C. And I know in the Pythagorean theorem, a squared plus b squared is equal to c squared. So a and b are both 1, so that's 1 squared plus 1 squared is equal to c squared. So that means that c squared is equal to 1 squared is 1, plus 1 squared another 1, so that's 2, which means that c is equal to negative root 2 and positive root 2 by the algebra, but we know that it can't be negative because we're talking about a triangle. So when the legs of the triangle are each 1, the hypotenuse is the square root of 2. Alright, let's move on to the next one. Again, here's my right angle at C. These are my two legs. And we're going to let AC be 2 in this case, which means that BC would also be 2. And again, I'll let this be C. So I know that 2 squared plus 2 squared is equal to C squared. So I've got 4 plus 4 is equal to C squared. And C squared is equal to 8, which means that C is equal to negative square root of 8 and positive square root of 8. And again, we don't use the negative one. And then I'm going to go ahead and simplify this. So 8 is going to be 2 times 4 and then 2 times 2. So this pair of 2's is going to come outside, so that's going to be 2 root 2. Okay, so over here, our legs had a length of 1, and the hypotenuse turned out to be root 2. Over here, our legs had a side of length 2, and our hypotenuse turned out to be 2 root 2. So hopefully you're seeing a pattern here. So now let's let AC be x. So I'm going to let this side be x. These legs are going to be congruent, so that's going to be x as well. Here's my right angle, and again, I want to find c. So I know, using the Pythagorean theorem, that x squared plus x squared is equal to c squared. So I've got 2x squared is equal to c squared. I'm going to take the square root of both sides and flip things around here, so I'm going to end up with c is equal to negative square root of 2x squared and positive square root of 2x squared. I'm going to simplify here. I don't need that one, which means that c is equal to square root of x squared is just x, so I'm going to pull that out to the front, and then the square root of 2. So I see when I have legs of length x, then my hypotenuse turns out to be x root 2. So we have a relationship, a ratio between the sides of all three of these 45, 45, 90s. Which leads us to the isosceles right triangle conjecture. In an isosceles right triangle, if the legs have length s, x, then the hypotenuse has length x root 2. That's what I found right up here. So then, a lot of times we like to talk about it in the ratio. The ratio of the leg to the other leg to the hypotenuse for the triangle is 1 to 1 to root 2. Okay, and sometimes we'll write this in terms of variables, and I just like to use the variable a. You can use whatever variable you want. I just sometimes stay away from x because it's used in problems a lot. So it would be a, if one leg is a, the other leg would be a, and that would make the hypotenuse a root 2. Okay, and then this is going to be a little bit more useful for us when we start solving problems. Alright, so that's going to be the end of this video. Once you're done with this one, you're going to want to move on to the next one, talking about 30, 60, 90 right triangles.